Welcome to this explainer. Today, we're going to take a look at YAML pipelines in Azure DevOps, and we're going to treat them exactly like what they really are, a highly efficient, automated software factory. If you've ever felt completely overwhelmed by the sheer scale of CI/CD configuration, well, think of today's explainer as your master blueprint. We are going to break down exactly how to build, control, and modularize your delivery process so that it runs like a well-oiled machine.
Okay, let's dive right into this and map out our factory. We'll start with the anatomy of a pipeline, move into the hierarchy of stages, jobs, and steps, look at smart deployment strategies, explore modularity with templates, and finally, handle managing multiple external repositories.
Section 1. Anatomy of a pipeline. Laying the foundation.
Before we get lost in complex syntax or advanced supply chains, we absolutely need to understand the basic skeleton of our factory floor. So, a YAML pipeline is essentially a version-controlled, declarative representation of your CI/CD workflows. What that actually means is your deployment process is stored directly alongside your application code. It brings modern, code-centric practices right to your infrastructure. Any changes to how you build or deploy are reviewed, approved, and tracked exactly like a feature update to your software. It's brilliant.
Now, every pipeline generally features a few core components that act as our initial blueprint. First up, we've got the name and triggers. This defines what the run is called and what literally starts the factory. Next, we have variables to store key value pairs, and the pool, which basically tells the pipeline which queue or agent machines to use. And finally, we have the actual work, jobs, and steps. But let's pause on triggers for a quick second because they absolutely dictate the heartbeat of your automation.
By default, if you don't explicitly specify a trigger, your pipeline is just going to assume you want to run it on every single commit to any path from any branch. And, that leads to a very real developer problem. How do we stop a pipeline from running on every commit and just wasting incredibly valuable compute resources?
Well, the answer here is trigger filters. You can precisely control when the factory spins up. You can include or exclude specific branches, or even narrow it down to specific paths. For instance, you could set it to only trigger when someone actually modifies the /webapp folder. You can also trigger off git tags or use cron expressions for schedules. And hey, definitely don't forget the often overlooked none trigger. If you set your trigger to none, the pipeline will literally never trigger automatically. This is absolutely perfect for strictly manual deployments.
Section 2. Stages, jobs, and steps. The factory floor hierarchy.
Let's move on and see how this builds into the nested macro-to-micro structure of Azure Pipelines. You can kind of visualize this hierarchy like Russian nesting dolls. Up at the macro level, we have stages. A stage is a major division. Think build, test, or deploy, and it contains a whole collection of jobs. Inside a stage, we have those jobs, which represent units of work, and inside jobs, we have steps. These are the actual linear sequence of tasks or scripts being executed one by one. So the crucial point you need to remember here is that jobs are atomic. The entire set of steps defined within a single job will always execute together on a single agent machine. If you have steps that absolutely need to run on different machines, say you're building a Windows app and a Linux app, you have to split them into two completely separate jobs.
Because jobs basically form the backbone of our execution, Azure gives us some really powerful attributes to control them. You can use depends on to specify that, hey, job B cannot start until job A finishes. This lets you create these really complex fan-in and fan-out parallelization graphs, meaning you can split work across a bunch of agents simultaneously and then just wait for them all to finish before moving forward. You can also use condition to evaluate true or false expressions to skip jobs entirely. You can dictate execution strategy and set the pool to target specific build queues.
Section 3. Smart deployment strategies. Delivering updates safely.
Right, so now that we know how our factory processes work, we also need to architect how we actually deliver our output to the real world. And this brilliantly illustrates two of the most effective ways to safely deliver updates. First, we have the rolling strategy, which incrementally replaces instances of the previous version. It's a smooth transition. Then, we have the canary strategy. This is where you deploy your changes to a very small, isolated group of servers first. It's a fantastic way to reduce risk, test the waters a bit, and build confidence before you roll out the release to your entire infrastructure.
To actually pull off those deployment strategies, YAML pipelines use what are called lifecycle hooks. These hooks dictate exactly what happens during a deployment job. You have preDeploy for initializing your resources, deploy for the actual app update itself, routeTraffic to start serving your users, and post-routeTraffic to monitor the overall health of the system. Best of all, you have on-failure and on-success hooks. These will automatically handle cleanups or even emergency rollbacks if things go south.
Section 4. Modularity with YAML templates, using prefabricated parts.
Let's be honest, writing the exact same sequence of steps 3 separate times for 3 different environments is a massive headache. Nobody wants to do that. We need a way to reuse code. Enter YAML templates. You can basically save reusable parts of your pipeline into completely separate files, essentially building a library of prefabricated parts. There are 4 types you really need to know. Stage templates are perfect for reusing an entire testing regime across, say, staging and production. Job templates let you repeat a build process on different platforms. Step templates allow you to share a specific sequence of tasks. And variable templates, they let you share common key value pairs across entirely different pipelines.
Just to give you an idea of the massive scale of architecture permitted here, Azure Pipelines supports up to 50 included template files in a single pipeline run. 50! That means you can build incredibly modular, highly sophisticated setups using all these prefabricated components managed by completely different teams.
Section 5. Managing multiple repositories, the external supply chain.
Our pipelines very rarely exist in a vacuum, so let's look at how they interact with external code bases. Imagine this scenario. Your pipeline is running perfectly, but suddenly, boom, your job requires a micro-utility script or a template that is housed in a completely different repository. How does your factory reach outside its own walls to get what it needs? Well, the answer lies in the resources keyword. Resources effectively act as the supply chain for our software factory. By simply defining resources at the very top of your YAML file, you can consume artifacts from other pipelines. You can pull in Docker containers to run isolated toolsets right alongside your job. And, crucial to our scenario here, you can pull in other repositories. It doesn't matter if they live in Azure repos, GitHub, or somewhere else entirely.
Now, what's really interesting about this process is how Azure actually handles fetching that external code. By explicitly declaring multiple checkout steps in line within your job, you can tell the agent to fetch your main repository and then immediately fetch a utility repository. Azure automatically maps these external repositories to named folders on the agent machine based on the repo name. It perfectly integrates your external supply chain with any fuss.
Of course, security is absolutely crucial here. If you are pulling code from GitHub specifically, Azure Pipelines supports 3 main authentication methods to securely grant access: GitHub App Integration, OAuth, or a personal access token. This ensures that your external supply chains are not just highly modular, but tightly secured.
Conclusion: becoming a CI/CD master builder.
We've journeyed all the way from the anatomy of a basic pipeline to the orchestration of complex, multi-repo, templated supply chains. But before we wrap up, I want to leave you with a highly practical tip. If authoring YAML manually feels a bit daunting at first, use the Task Assistant in Azure DevOps. It sits right inside the editor, allowing you to select tasks graphically and configure them via a UI. It'll automatically generate the proper YAML syntax for you and catch any missing parameters in real time. Seriously, it's an incredible learning tool.
So I leave you with this final question. Are you ready to migrate your classic pipelines to YAML? You now have the master blueprint to make your CI/CD workflows version-controlled, modular, and highly scalable. It's time to take control of your software factory. Thank you so much for joining me on this explainer, and happy building.